Some people are still missing. 1, 2, 8, 10. So 3 people are missing. Okay, I presume all of you have your laptop ready. So, no, we will go into MATLAB after 15 minutes, not now. But within 5 minutes, you should be able to put on your MATLAB. But right now, on your laptop, keep this particular discussion available. Don't go to MATLAB right now. You will go to MATLAB after 15 minutes. I think 2-3 people are yet to come. आदित्य कहाँ पे है? साहिल कहाँ पे है? साहिल?
Yes, sir.
Sahil, you know that HOD has not allowed audit registration. He has turned down. Your application was put before Thomre sir, HOD. He has turned down audit application saying that a department student cannot audit a subject of the same department. He can audit a subject of another department. He cannot audit a subject. I didn't agree with him, but he is in chair. Okay? So he is in chair. So that is his decision. It's not a happy thing for me, may not be a happy thing for you. So now you have a choice to delink yourself or continue attending it. कोई ज्यादा ट्यूशन फी नहीं देना पड़ेगा, ठीक है? Fine. Can we start, Shraddha? Who is missing? Aditya is missing, I think. I see only 11 people. There should be 14, no, 12 plus 3, 15 people. Okay, they will possibly join little late. So we will have 15 to 20 minutes discussion on transmissibility. That is our lecture yesterday. And then we'll go to MATLAB programming. ठीक है? तो ये कौन है पहले? नंदना? Nandana is there. ठीक है? Nandana, I can see. Aditya has just joined. Yeah. Shraddha, late भेजा क्या link? No, I have myself sent link to all these people. So they cannot say late भेजा है करके. 13 हुआ है. So Aditya has just joined. So other people will also join. ठीक है? Some. Now you can take out your camera and let's have the discussion on my vibration isolation. Okay. Now, in yesterday's discussion, this quantity was derived. This is a very important formula. Separately, you should write down. This is a very important formula. This was derived yesterday. In exam, I will never ask you to derive, but you should follow how it has been derived. But ultimately the formula is important. So in force isolation, transmissibility is given by this formula. Now, what will be how the formula will look if damping is 0? How the formula will look if damping is 0?
1 by mod of 1 minus r square.
So that is correct. Don't write 1 by 1 minus r square. 1 by modulus of 1 minus r square. So if that you write down, because that sometimes we may need undamped condition also. And the formula is very simple. Formula is very simple. So undamped condition transmissibility is 1 by modulus of 1 minus r square. That is one thing I wanted to add today. Another thing, this graph, I like very much. And let me tell you, in vibration, we have to understand a formula, either looking at the formula or we have to understand the formula looking at the graph. I like graphs because when we look at the graphs, we learn many things. So yesterday, let me repeat what we learned from this graph. We learned that irrespective of damping, all the graphs intersect a common point at frequency ratio root 2, and at that point transmissibility is 1. What is the meaning of transmissibility is equal to 1? It means the disturbance force as it is getting transmitted to ground. That is the first observation. Second observation is that if the frequency ratio is less than root 2, transmitted force is more than the actual force. It is bad. Third observation is transmitted force becomes very large if the frequency ratio is close to 1. Or in other words, at or around natural frequency, we should never operate, because in that zone, transmitted force will be 5 times, 6 times larger than the actual force. And the best thing we learn is keeping the frequency ratio greater than root 2, because if we can keep the frequency ratio greater than root 2, then transmitted force will be less than the actual force. So this I'm repeating what we discussed yesterday. Now, I ask you a question, simple question. You have weight of the machine. Agree? You know what is mass of the machine. You know what is the frequency of disturbance force. Means, how do you know? You assume that the machine has unbalance, and if the machine has unbalance, obviously its frequency will be frequency corresponding to RPM. So if it is rotating at 1500 RPM, its frequency will be 25 Hertz. If it is rotating at 750 RPM, its frequency will be 12.5 Hertz. So in industry, you have joined, and your manager, your boss has taken you to a machine whose mass you can find out, and frequency of a possible unbalanced force, that also you can find out. Take it. Now, what the boss did, he bolted this machine without any isolator to the ground. And when the machine was running, he found that lot of force is getting transmitted to the ground, and ground is also vibrating, which is not a good phenomena. So now he gives you a project कि भाई कुछ करो. क्या करोगे? My question is क्या करोगे? सोचो, 2 मिनट सोचो carefully, and then you give the answer. क्या करोगे? Remember, boss did not use any isolator. He bolted the machine directly to the ground, and when he started the machine, he found a large force is getting transmitted to the ground. Be careful. I'm not asking an ordinary question. This is an excellent question. So you have to answer properly. I'm giving you time.
Sir, we can add rubber buffer.
So the first decision is go for an isolator. Agree?
Yes, sir.
Yes, sir.
The first decision is go for an isolator. ठीक है. उसके बाद अब आइसोलेटर मार्केट में तो 1000 मिलते हैं. कौन सा आइसोलेटर लगाओगे?
Sir, we can find out omega by using that frequency and then omega by omega and ratio, and according to that we can select.
See, this is the problem. Why today people are not getting job? You are giving answer, you give a practical answer. Do you think on isolator omega n is written?
No, sir.
Then give a practical answer. You go to the market to buy an isolator. ठीक है?
Yes, sir.
अब दुकान वाला बोलेगा कि भाई आइसोलेटर हमारे पास 1000 है. आप डैम्पिंग बोलो, स्टिफनेस बोलो.
Sir, we know the mass, right? So we can find out the stiffness by using omega is equals to root over k by. Can we post it with that?
See, you have to be very careful. I am not saying what you can do. I am asking what you will do.
Yes.
You have to survive your job. So what you will do? Suppose omega rotating frequency is 25 hertz. What you will do? And mass is 1000 kg. Okay. Mass is 1000 kg and rotating frequency is 25 hertz. What you will do? You go to the market to buy an isolator. Aru, is the window still on? Okay. हाँ, ठीक है. Fine. So where is the answer? I have given a specific information. Rotating frequency is 25 hertz. Mass of the machine is 1000 kg. So what do you do in the shop? Which isolator you will buy? Will you buy a rubber pad isolator or a helical spring isolator?
Sir, helical spring.
क्यों?
Because it has max stiffness than rubber.
No. He says that stiffness you can get from rubber pad also, suppose. Stiffness isn't a problem. You can get it from rubber pad, you can get it from helical spring also.
But sir,
Sir,
there
it
is
has
also
Huh?
absorption of.
Sir, it has less damping.
It has?
Less damping.
Correct. Helical spring is made of metal, damping is less. Rubber, damping is large. So, should we go for large damping or less damping?
Less damping.
So, we go for helical spring. But what is the stiffness you will settle at? Now, he has 100 varieties of helical spring having 100 different stiffness values. what stiffness you will buy.
Greater than 24.64 mega Newton per
Again,
meter.
see, you have to maintain your job. You cannot say greater than. You have to come with a value. ये सब
25
बातें
mega.
इंडस्ट्री में नहीं चलती है. You have to come with a value. So you have to answer with a value and then answer. Okay, this is why I'm settling at. So I want a value and then why you are deciding that particular value.
Sir, 25 mega Newton per meter.
Why 25 mega Newton per meter? What will be frequency ratio?
It will be greater than root 2.
See, again you are giving an answer which is irritating me. You give me exact value 25 mega Newton per meter. Will you not get an exact value of frequency ratio?
Yes, sir, I will get.
See, this is the reason why nowadays engineers are not getting a job. They get a degree and then they think that they should be given a job. I have worked in industry for 13 years. If you are saying it is 25 mega Newton per meter, you should also calculate what is the frequency ratio. What about other students? Why are they silent? They are not doing anything. Only 2 MTech students are answering. BTech students are totally remaining silent.
The ratio will be 0.992.
So 0.992 will you, I mean, that is a dangerous situation. You are working near resonance.
Oh, I calculated.
No. I don't accept your answer now. You will lose your job. You are recommending a dangerous situation when transmissibility will be very, very large. My UG students, you are not answering anything. I am asking you a real life problem. If you cannot answer real life problem, then don't expect that you should be given a job from industry. Okay, I leave it up to you. I think I cannot spend more time on it. So I leave it up to you, but it was a very, very practical question. Question remains. Think over it for 2 days. It's not an ordinary question. And remember, why an engineer should be paid 10 lakhs or 15 lakhs package? He has to answer this question. If he cannot answer this question, why he should be paid? So think over it. I am giving you again 48 hours. We will again come back to this discussion on Tuesday. But let me go back to laptop, MATLAB. So all of you start MATLAB first. And you can connect this PPT through your mobile, because you will require both. You will require MATLAB on your laptop, and you will require a PPT also simultaneously. You can have it in MATLAB. You have to toggle the windows, or you can have the PPT in mobile.